Hello, welcome back to Computer Communications course. This is the last recording of Chapter 2, where we finish consideration of the functionality of the application layer of the communication stack. And today we will consider basics of socket programming, both with reliable transport and unreliable transport. Socket Application Programming Interface (API) is a very important mechanism for computer communications. It is, in fact, a reason behind one of the main reasons behind the success of the current internet technology. It was first introduced in 1981 in operating system Unix, and it offered two types of transport service to the application programmer. An unreliable datagram service implemented by UDP protocol and a reliable by stream oriented service implemented by TCP protocol. Let us see now the principle behind a client-server socket programming using TCP protocol. So we have our client-side program and a server-side program. In order to enable the client-server interaction, the server process must first be running, and the server must have created a socket that welcomes client's contact. Our client contacts server by creating a client local TCP socket here, specifying the IP address and the port number of the server process. When this client socket is created, the client TCP establishes a connection to the server TCP instance. To do so, when contacted by a client, the server must create a new TCP socket specifically for this connection. So during this step, as I mentioned already, the client and the server establish a TCP connection. Later on, the client and the server may actually start exchanging the data. So the data will be sent to the local socket at the client side and read by the connection specific socket at the server side. So by this mechanism, the server process may communicate with multiple clients. So at the end of the communications, when application indicated, the connection is closed explicitly, and the TCP connection is terminated as well. From the point of view of an application level programmer, TCP socket is used as a stream. A stream, in general, is a sequence of characters that flow into or out of a process. So an example of an input stream, for example, could be a keyboard. When you type characters on your keyboard, so these characters are available inside the program via a standard input-output stream. So socket is no much different, actually. Socket is the stream where you can input your data. In the same way, socket may be considered as a source of data. So whenever TCP protocol receives data, this data becomes available for a programmer as an output stream. Let us see now how we can implement a simple client-server program in Java. This program will do the following. The client side would read an input from a standard input, so from the keyboard, And so we will name this input stream in from user, and it will send this input into the socket, so to the server, using the socket out to server here. So the server will read the received line, convert it to the uppercase, and send it back to the client. So when receiving a reply from the server, the client will read it and print the modified line. So first of all, we need to include this package into our program. This package contains all necessary classes for creating and operating sockets. So as I have already mentioned, here we create an input stream. Here we create a socket to a specific host name and a port number. So by executing this line, a TCP connection will be established. And then we connect we connect our output stream. So we create an output stream into which we will write the characters and connect this stream to our socket, so that the characters would end up in the server. Finally, we create an input stream attached to the created socket. So in the first line of this slide here. And now we may implement the functionality. So we read a line from the standard input, so our characters from the keyboard, terminated by carrier return sequence, carriage return sequence, and we send this line over to the server. So it is as simple as just writing bytes of this red sentence into the output stream. So in the next line, we actually read the response from the server. So in between, all the communication and the processing happened on the server side. So, and here we print it out according to our application. And at the end of our program, we close the socket, terminating the TCP connection. So let's see what happens on the server side. So we also write the server side of the program. So first of all, we create a welcoming socket in this line. So we create a socket which would wait for incoming connections on port number 6789. And then we have an infinite loop here, while true, where we wait for connections. As soon as the request from the client arrives, so the TCP connection is established, so we have created a connection-specific socket at the server side. So it is called, in our case, connection socket. So we basically create the input stream at the server side, where we read it, where we read the input from the newly created socket. We create an output stream and attach it to the socket in the first line of this slide over here. So we read the line. So now when the infrastructure is established, is implemented, so we created an input stream and the output stream. So we do we implement the actual functionality. We read the sentence from the input stream from the socket over here. So we capitalize this sentence and write the bytes into the output stream, which is connected to our connection socket. And that's it. Let us see now the peculiarities of socket programming using unreliable transport which is implemented by UDP protocol. Remember that UDP offers a connectionless service, meaning that there is no need for a handshake procedure. The sender explicitly attaches IP address and the port destination to each packet. So the role of the server is to extract the IP address port of the sender from the received packet. So let's see the principle of using UDP sockets on a time diagram. So first of all, a server creates a process and it opens a server socket. So now it opens the datagram socket. So please note here. So the client side opens its own copy of the datagram socket over here. And without any connection establishment, so the client prepares a datagram with the server IP and IP address and the port number, and sends this datagram over the client socket, like this. Upon the reception, this datagram is read from the server socket. Client IP address and the port number is extracted. So the functions according to the application logic are performed, and the reply is written back to the server socket, and by this the packet is sent back to the client. So at the client side, this packet is read from the client socket and the socket is closed. Remember that opposite to the TCP sockets, which offer a stream service where we submit a stream of bytes to be sent to the client, using UDP sockets, we operate with packets. So the application should prepare a data structure, a packet, and submit it to the UDP socket. It is illustrated in this figure. So the client process prepares a packet and submits it to the client UDP socket. This packet is traveled across the network to the server side, and the reply is received also in a predefined structure using the packet class, which is then is transmitted to the application process. In the class, I will show you an example of how the conversion client service program that we implemented with the help of TCP sockets can be implemented using UDP sockets. The important thing to remember here is that UDP offers an unreliable transport service. It means that the packets can be lost in the network, or they could be delivered out of order, which makes the UDP implementation of the same service highly dependent on the network conditions. By this, I would like to finish consideration of the application layer of the communication stack and the overview of chapter 2 of our course book. We covered a lot of topics, starting from application architectures, going into details of certain popular client-server and peer-to-peer applications, as well as learned some basics of socket programming. So next time we start considering transport layer, chapter number 3. Bye-bye.